final chapter, chapter 18, maintenance and troubleshooting. Objectives: care for testing equipment. Very important. You got to take care of your test equipment. You got to make sure that it's going to work when you need it and it's not going to hurt you. Troubleshoot a power circuit, power supply, control circuit, control transformer. Identify major case of motor breakdown. Explain the importance of preventive maintenance. Perform several troubleshooting tests. This is they're just checking the temperature. Yeah, there's a variety of them. Here's mine. So I also have one. I'm a Ampro person, as you can see. Name brands, Ampro. They're using the Fluke. Fluke, I like them too. I have my pocket testers. Even my old one from way back when. This one doesn't have an audible. This one has an audible. Tip broke, but I can still use it for showing. I wouldn't use it because the little plastic thing broke off, but it still works. But it's also so many years old. Again, I also have for doing temperature test. Okay, check wires, check motors, make sure it's not getting hot. Troubleshooting. It says today's business require high production, cost-effective process and minimize downtime to remain competitive. So what they're talking about is when you're working in a factory or something and the power has to stay on, the machines have to run. Guess what? They can't make money. The machines break down, or the machines are always stopping. Now you got that machine's not producing, and then you have somebody standing around. Okay, so while I'm trying to work on something, guess what? Let's say you got a machine that's got 4 employees, and the machine's down for an hour, 2 hours. Well, now you got 4 employees standing around waiting for you. So it's taking care of things. Make sure everything runs to minimize downtime. And must be a lot of times they have when I worked at the slaughterhouse, sometimes we have to stay late to do things. Guess what? We had to go grease machines up, power levels. Once the pumps went off, make sure our fluids were at a certain level for our hydraulic systems. So everything had to be done at a certain time. Okay, we'd get in there and we checked machines. All machines were built, all belts were checked once a week. Before we turned on the machines, I had to come in at 4 o'clock in the morning and do maintenance, because we started at 6:30. Sometimes I get there about 3 because I have to do preventative maintenance on some of these equipment. Check belts, make sure they're at proper tightness and everything else. Make sure bearings are greased and everything's working properly. We had some hydraulic pumps. The hydraulic pumps have to work for 2 hours before you turn them on, before you start using them. So they have to run to warm up. Okay. And it goes on. This chapter will look at the subject of maintenance, testing, and troubleshooting techniques. A strong emphasis is placed on motors, which is typically the most expensive individual component as well as the most crucial to operations. So this goes back more. I'll try to throw some other things in, but it goes back on motors. When we're doing the residential electrician too, we talked about troubleshooting also, and that was troubleshooting circuitry and using your process of elimination. Okay, where's your problem? I got a circuit that's down. Well, my panel is here, and I got an outlet that aren't working. So I always go in the middle. Okay, from here, this way it's not working. From here, that way it's not working. Okay, go check. Take the wires out. do resistance, get my thing, put it on ohms, and do an ohm test. Okay, on the wires, make sure I don't have a short circuit or a ground fault. Going that way, or is it going that way? So now I can tell which way to start looking where the power may be. Yeah, when a breaker trips, you just don't walk up and reset it. When a breaker trips, you just don't walk up and reset it. You got to find out what caused it to trip. What caused it to trip? It says commercial electricians are frequently called to solve electrical malfunctions. Often these electrical failures are simple and can be easily remedied. Okay? What does that mean? Well, you go and you check out simple thing, breaker trip. You know, you go in and they say, hey, you know what? In the break room there's no power. And you walk in and what's not working? The coffee pot, the microwave, and the toaster oven. And there's only one circuit. And there's a sign that says only use one at a time. But people don't read signs and people don't pay attention. Hey, all I know is I gotta heat up my lunch. So somebody goes throw something in the toasty oven, somebody goes throw something in the microwave, power goes out. It's a very simple fix. You know, breaker trip, overload. There's no short circuit, it was an overload. Okay, so it's simple things like that you can tell. You go in there, somebody called you in an office. Oh yeah, we lost power here. And you walk in and here's 10 computers and 2 copiers. What happened? Well, we were just making copies and the power went out. Okay, that means that all those computers were on. If there's a bunch of people and all those computers are on and they try to send, the computer uses 3 to 5 amps, maybe 6, depending on monitors and everything else. Depending on the size of the monitors, or 3 to 6 amps. So, and you got 10 computers at 3 amps each, that's 30 amps. What caused the breaker to trip? You got a 15, 20 amp breaker. And you're running 30 amps through it just by looking at the computers. Process of elimination. Easy. When using test equipment. Follow general rules and use care. It says in order to determine what is wrong, an electrical system testing equipment is needed. The better the testing equipment, the easier the job. So it all depends. They make all types of testers. I don't have my multimeter. For most parts, this is what I use. You can use a multimeter, but this one does everything for me, just like a multimeter does. Reads amperage. I don't have to worry about having a special loop to tie in to read amperage. That's why I like using Amprobe. I have a couple other ones, but my son borrowed them, so I don't have them. What happens when you have kids? They try to get into the field, and then they need tools. Well, where do they go? Where do they go to get the tools? Daddy. So they got tools, so now I got to get tools for myself. But this does everything for me. I don't need my Fluke T5. Alright. So it says follow general rules. It says keep test equipment in good, clean storage. Keep test equipment in good, clean storage. Make sure all components are in proper condition and are well maintained. Be sure internal fuses, power supply cords, and batteries are in good condition. Yeah. Make sure your battery's in good condition. Why? Well, you need it and the battery goes dead and you don't have another battery. Or keep a battery or handy just in case the battery goes out. This happened to me a few times, but I always have a battery in the bag. I don't have one now because I changed it. I just haven't replaced it. So always, my Amprobe is always in this pouch. I have a couple of them. They're all in their pouch. Okay, to protect, take care of them. My heat gun comes in its case, so that way, to protect it. I need to carry it. There's also the pouch so I can carry it on me. Keep the test equipment, instructions, booklets, and refer to them when necessary. Okay? I'll bring mine out. Here's all my information for my amp probe. Anything I need to know. What kind of test I can do. With mine I can do temperatures. For temperature. Okay? Also. I keep everything in this little bag. In the case. If I ever need to go back and look at something, I can refer to it. Excuse me. Use test equipment for its intended purpose. Okay? What is intended for? Okay, this one does voltage. I can check resistance. I can check continuity. I can check temperature. I can check amps. Voltage I can do AC or DC. Amps is only AC. Okay? These are only good for AC. Same thing. I don't recommend, I don't think they even make these anymore. This is a non-audible. This is an audible. This one doesn't do anything. That batteries aren't in it. Okay? Because if you're working with someone else, they hear this thing beep, guess what? Now they know that the power's on. If you're working in an area and they can't see you, they don't know if power's on or off. Because they can't hear, in case they can't see you. Happened to me a couple times. I'm underneath the desk. My helper can't see if power's on or not. So if they know that power's on, all of a sudden I start kicking. Oh, it's getting electrocuted. Something's wrong. Okay, if I got one of these, they don't know if power's on or off. Do not push the equipment beyond its maximum rating. Okay. Voltage wise, this one is 600 volts, 1000 amps. Even though it's got a bigger, I can get it around bigger wires, but it has a limit on it. Same thing with these. These are 1000 volts. This one isn't. 900 to 600, 90 to 600. The other one's the same thing. Okay, don't go over its max. I have a couple of smaller amp probes, and those are only rated at 100 amps because they're smaller. Okay, voltage is 600 volts, but the amperage is 100. That one goes up to 1000. I don't want to go over 100 amps and use it. When using an instrument with several scales, always test with the highest scale to prevent overloading. Okay, so if you have a multimeter and the multimeter has, say, 250, 480, and then a 600 or 700 or whatever it may be, go to the highest rating. It's still going to read it, especially if it's a digital. It's still going to read the voltage. It doesn't matter. It's going to give you a voltage reading, so it's not going to hurt anything. Okay. Same thing with if you do an amperage. Take it to the highest level. With these, that's what's good. There is no levels. Just got to make sure when you put it on, what are you doing? Are you doing voltage? Are you doing amperage? Doing temperatures? Or are you doing resistance testing? Okay? So you just move it to wherever you need it. Because it's already have a high setting on it. When making resistance measurements, never work on an energized circuit. So when you're using this, and I'm testing, drop something there, a receptacle. And I want to check if my wire is good between this outlet and the next outlet. Okay, so basically I'm going to go across here. Last thing you want to do when you're on the resistance test is have power on. What this does is it sends out a voltage signal. Then it gets back, that's how it reads the resistance. Okay. So it sends out a signal and it comes back. Well, if this goes in, a lot of these have a fuse inside to protect it in case you do it. Okay, so it does have a fuse to protect in case it does do it. So you have to be very careful when you're doing resistance testing. Or continuity. Check it for continuity. Okay, make sure power is off. Make sure power is off. Voltage, no voltage present. No voltage present. Make sure clamp on instrument jaws are completely closed and on one conductor at a time. Okay, so when you're testing, one wire. Okay, it's like if you get this and you put it around the cord, there's a cord here, and it's got something plugged in. If you put it on the amperage, and it gives me nothing. Well, what it's doing is it's reading that hot and neutral. That hot and the grounded wire. Well, what happens if I got 5 amps here and I got 5 amps here? Well, what's a 5 amps going to do to the 5 amps here? It's going to make it 0, so it's going to give you no amperage. So you only want to do one wire at a time. Never try to get around a cord and check that way. They do make a plug-in one that you can plug into an outlet. I don't have it. Never used one. But you plug it into the outlet and you just clamp it. Now you can read amperage going across that outlet. It's a good little thing. I've never needed it. So yeah. And if I had to measure amperage, I pulled the receptacle out and clamped around the wire, around the hots, and found amperage that way. Or go back to the panel and read the amperage of the circuit. Okay, so what you're looking for and what you want to do. And make sure the clamp is closed. Okay, make sure the clamp is closed, that it doesn't get stuck. Partially, so it can read the amperage. They do make these open jaw ones where you just stick it around the wire. Inspect insulation on test leads before, after, and looking carefully for any cuts, abrasions, or nicks. So you're always, if you keep them locked up, safe and everything, but these can get brittle. The plastic can get brittle and start to break. The last thing you want is this have a nick. Guess what? You're looking, you pull it back, it goes over a sharp edge, but you don't catch it, and you don't inspect it, and all of a sudden you go to grab it to test something, and that area is nicked right in that area. Well, guess what? You're going to be that light bulb. Yeah. What happens to a light bulb when it gets electricity to it? It gets lit up. So always test to make sure you don't get lit up. Okay. Make sure your tester is working properly. Check it. Your battery, turn it on, make sure it comes on. Go to ohm test. I like to do this every once in a while. Just go and check them to make sure this moves. Okay, so it tells me that it's working, and then all of a sudden I'll see it go blank. As soon as I want it to do something, the screen goes blank. Okay, that tells me that the battery is not working properly. Observe all safety rules while testing. So when you're testing something, make sure you keep yourself away from things. Wearing the proper, ain't nothing wrong. With having on the proper PPE when you're testing things. Okay. Lockout, tag out. The lockout, tag out kit. Turn power. If you got to shut something down, you have to work on it. Lock it out, tag it out. And this is my little kit here. fire resistant, fire retardant, whatever you want to call it, an FR shirt. Yeah, to protect you. Long sleeves. Protect your arms. And the other is hot gloves. These hot gloves are good up to 1,000 volts. Make sure you test them. Keep them. I keep mine, as you see, I keep mine in a box. So that way, whenever I need them, I keep them in the box. My shirt, whenever I'm going to work in a panel or anything, I'll put it on. I usually keep that in a plastic bag. Okay. Troubleshooting methods and procedures. Find the correct problem as quickly as possible. It says troubleshooting consists of finding the correct and correcting the problem. The goal is to do this as quickly as possible to avoid costly delays. Equipment downtime. So it's always important is trying to get this up as possible. So you have to have an understanding of the functioning of the equipment and the circuits. It says so when troubleshooting it is important to understand. Okay, and how are you going to find the correct problem? How are you going to find what caused the problem to go out? Well, you have to know how the machine works. You have to know how the machine works in order to try to find out what caused the problem. Sometimes you may have to find a schematic because you don't know how it's wired, so you have to bring out a schematic where it is. So you may have small relays here and there. I'll talk about small relays. You know, the ice cube ones, these can go bad. Contactors, I'll get those later, but a contactor, a relay, a timer relay, guess what, that timer goes bad, and let's say it goes into motion, and when it goes from step 1 to step 2, it's got a 10-second delay or a 30-second delay. Well, they do step 1, but it doesn't go to step 2. Why? Well, maybe that timer's not going. We'll get into that later. Use the process of elimination. There will be certain parts that can be easily checked. For example, the power connection to the supply. So the process of elimination. Okay, where do you start? Machine stops working. Where do you start? Does it got power? My first thing, does it have power? You know, going over to the panel. Does this got power in here? So if my power's there, but I always go back and check my power from the supply side. Okay, so it's off the main breaker. If it's off the breaker, is it coming over and feeding that motor? Even though there's a disconnect, but at the breaker where it starts off, is there power there? There's power getting to the disconnect. You know, process of elimination. So it says, for example, power connection to the supply, circuit breaker, and fuse can be quickly checked. Check is a distinct part of the equipment. Test the line side of the power circuit, then the load side. And move to the control circuitry, move electrical. So you start process of elimination. Okay, you start off at your supply. Okay, you can check it at the disconnect. You can go over to the disconnect. Am I getting power from the disconnect? I'll go over to that. I hope the drawing's on there. I forgot to check. It says use a voltmeter to confirm voltage and the level of each incoming line. Use a jumper to isolate the control circuit from the power. So what they're doing is they're jumpering the stop starts, and they're going straight to the contactor to close the contactor to see if the motor comes on. So they're going straight to here, or you can use a screwdriver or something and then push the contactor in. my big contactors. Contactors are at school. I do have these little ones. Okay, this part right here in the center. Get something. Push it in. If it closes and the motor comes on, and then we know where a problem may be. So it may be somewhere in these stop starts. So these starts, switches, or the contactor, the auxiliary contact is not closing and holding. So that's one of the things that we have to check. Your overloads. Okay. Is my overloads causing the problem? These are all part of the controls. So we're bypassing our overloads and everything else. We're bypassing our stop starts, I'm sorry, not the overloads, by pushing it in. And I don't know if you can see if it's, there's this little blue part right here in the center. Pushing down. Okay. And that automatically closes, so the motor should come on. Okay, and then from there it goes straight to the overloads. Well, it might be a problem with an overload, it might be a problem with the motor, anything else. And this is a timer I was looking for. So this one goes from 0 to 30 seconds, so you can get the timer, put it on whatever, and then it comes on after you hit that stop start. So you don't want it to come on when you hit the start button, so you want a delay, so this timer goes in terms of what goes on. Okay. Leave them there for now. I may need them later. Okay, so they're just going straight to here, or you can push it in with a screwdriver. So you just put a jumper, and in this one, a jumper would go from my number 1 where the line is, and then I want to go to the A2. So I want to go from L1 to A2 here on this one, and then that will turn it on because it bypasses here. Okay. Number 4 here's number 3, here's number 4, and here is this one. Here is the A2 is the this. On this one here, A1 would be here, A2 would be here on my contactor. So from the L1 I would go straight to the A2, and then right down here it's got A1, A2. A1 is my neutral or my other hot, and A2 would be my hot. Obviously this is from figure 18.2, where a manual motor starter, use a screwdriver to close the contacts. Once the contacts are closed, check to verify that the voltage is at T1, T2, T3. So if you close this, and here's T1, T2, and T3, if you got voltage at the bottom, and then the problem is with either the motor or your relays. Okay, so voltage comes across here. The other thing is the contacts on this. If there's no voltage, if you close this, you have voltage on top, but no voltage at the bottom. That means your contactors insides are gone. So it's not making contact. As it closes, it's not making contact. As this closes, the contacts are not making contact, so I don't have voltage coming out here. I have voltage coming here, but I don't have it coming out here. Troubleshooting the power source. It says troubles are often encountered at the power supply of the circuit. Find reasons for normal failure, and then it says find reasons for failure of protective device. So if you go in and you go to the power supply of the circuit and the breaker strip. Okay, so the circuit, the breaker tripped. Please bear with me, I'm trying to find a breaker. I thought I had one here with me, but I guess not. I didn't get one out of the garage. Thought I did. It says, when this case says a breaker may trip or a fuse may blow, creating a problem. In this case, the reason of the failure and protected device must be found. Okay, so before you turn power back on, what caused that breaker to trip? What caused that breaker to trip? What caused that fuse to blow? Okay, again, I talked about it earlier as a process of elimination. So you go back and you have to see what caused it. You know, I use the example of in the break room. Okay, obviously it was an overload because he turned on too many things at one time. Or a computer room or whatever it may be. Okay, but you go in there and it just, hey, what happened? I don't know, it just went off. Breaker, and then you go back and the breaker's in the trip position. And the breaker's in the trip position. Well, what do? Find out what caused that trip first. Find out what caused that thing to trip first before you're resetting. I have the contactor that I showed you all at school that happened to me at work. I got called in and said, oh yeah, the overload's tripped. Can you change out the overloads? I said, sure. And I went to go do it. He goes, oh no, we're doing preventive maintenance and we did something and I think we just tripped the overloads. So I took it as they already had checked everything. They did preventive maintenance, they did motor check, clean out, they did whatever they did. So I assumed that it was just the overloads. So I went and changed the overloads. Now I'm sitting there getting ready to hit the start button. And I said, you know what, Mundo, why don't you just practice what you preach? You know, so I said, well, you know what, so I went and grabbed the cover, put the cover on, locked it in, and, you know, I'm right-handed. So, like I always say, use the hand you don't like. So I took a step to the right, and I used my left hand to hit the start button. After I turned the breaker on, and I reached up there and I hit the start button. Just turned the motor on. Boom! Blew the cover off, hit me in the hand, clover flew to the back. And, you know, now to this day, I start thinking back and I start reading about these concussions and everything else. I had a concussion that day. I'm in a small room with concrete walls, and I had this loud explosion. And I had two phases that were grounded out to each other, or grounded out. When I went to check back, two of them were grounded out. So I took somebody's, I could have gotten injured. Okay, if I was standing in front of it like I started when I started off, here it is here, I was getting ready to hit, I mean here it was, right here in front of me. I was getting ready to hit the start button. I said, I'm going to practice what you preach. Put the cover on, step to the side, and then did it. Okay, showed you all the cover, pictures of the cover. So all the lettering inside on the cover were gone from the flash. It was so high. I would have done all in my face. Yeah. So, never listen to somebody else. Follow your steps. If they said, oh yeah, I did that. Grab your tester. Only takes a couple seconds. Take care of it yourself. The failure is normally a result of a short circuit or a current surge, but it must be investigated and resolved before replacing the breaker or fuse. Okay, so make sure you figure this out. Find the reason and failure of the protective device, normally a short circuit or current surge. Okay, what caused it before you do it. Even before checking, make sure there is power up to the protected device. See, okay, so verify that power is at the protected device. So you go to the breaker, you check on, you know, you got your breaker. I don't have one with me, so my breaker is bolted on this side, and this is where my wires go out that way. So my breaker, here's where the wires come in. Okay, I check here. The breaker's in the on position. I check here, and this says no power. Guess what? I want to check on the source. Make sure the source is hot. Okay, so you want to verify that this has power coming into it and it has power going out of it. Even with the breaker off, you can't check it on the outside, but you want to make sure power is coming in. If power is present, the breaker or fuse should be checked. Connect one side of the voltmeter. Let me go to the next break. So first we verify that we have power. Once we have power and it's still not working, and then we can go back and we can look. Oh, they don't have it. Most important picture is not on the PowerPoint. Alright, well, I'll use this picture. They're figure 18.1. So with my amp probe, I want to verify that I have power coming in at the top. So let's say this is a 240/480. 240/480. I'm just going to say voltage out there. So if I come up here and I go across my fuses, I should have 480 volts. If I go to a grounded part, so I got conduits coming into it, so I get one, I touch a conduit, and then with the other one, I'm touching the conduit with one. Now I touched here, I should have 240. I touch here, I should have 240. Okay, so that tells me if I got my 480 and 240 volts at each one, it tells me that power is present at the disconnect. That power is present at the disconnect. Okay, now with the disconnect on, I can check across here. Okay, let's say I don't have nothing. So that tells me that one of those fuses isn't working. Why? Because I need two wires. In order for this thing to work, I got to have two connections. So if I'm going across two hots and one hot's not working, guess what? It's not going to give me anything. Okay, now I can go from here to the ground. I got 240, I got 0. That tells me this fuse is red. How else can I check? I can go from here to the top, from here to the top here. That should give me 480. I should go from here to the bottom of the fuse. It should give me 480, but it's not giving me anything. Again, now I found out this fuse is not working. You have to go across, measure across, in order to read from this phase to this phase, and you should get your applied voltage. So if you go to the main breaker, which is up here, and I go to this breaker and I touch across here, and I got 480 volts. So now I know what my applied voltage is. Now I know what my applied voltage is 480 volts. So I should be able to measure it. Here to here, here to here, here to here. If I'm not getting down here, obviously one of my fuses is not working. Obviously one of my fuses is not working. Okay, I can go from the ground to the hot, to the hot. If I'm getting 240, 240, it's good. 240, 0, my fuse is bad. Okay, and on figure 18.1, when you look at it, your book, all they did is just what I did. Because they got 3 phases, they're going across all 3 and they're doing it again. Here, control voltage. We'll get into the control voltage later. That's the next one. So it's up to we're up to the troubleshooting the power source, so making sure our power source has power. Troubleshooting control circuits, we'll do that tomorrow. Alright, again, along with the video, I will be sending out a question sheet. So watch the video, do the questions. I know we had trouble getting the test out to you last week. So there's an example of some of the questions. All these questions that are on here, I covered them and I've talked about them. So you can't say that they're in the book, but I also brought them up and talked about them in detail so you would know the answers. There's a total of 8. There's a total sure you get it in. I'll send it in the email. It will also be on Schoology. So if you can't find it, if you can't download it, check Schoology. So everything that I do, I send out, I stick it on Schoology also. Okay? Y'all have a good one. Stay safe. And please, if you don't have to go out, don't go out. Too many crazy things are happening out there. I don't want to get into it, but you know, you're safer at home. You're safer at home. This pandemic, you know, don't play with it. I talked to my doctor and he told me, Mundo, stay indoors. That's it. The orders are stay home. You know, if you don't have to go out, stay home. Y'all stay safe. I'll see you on the next video tomorrow.